Okay, so this video is going to give a little bit more help with conversion factors in a specific scenario, which is when you need to use conversion factors in more than one dimension. When you're dealing with something like square meters or cubic meters and you need to convert your units, you have to be a bit more careful. And so I want to show you how that works. So if I have, for example, 10, whoops, 10.2 square meters, and I wanted to know how many square centimeters that was, I would need to apply conversion factors. But because we're talking about square centimeters, right? We're talking about an area that might look like this. Doesn't have to be a square, but it's easier to talk about. I have to convert units in this dimension, the x dimension, and in the y dimension, which means that I need to convert the length here in meters from meters to centimeters. And I need to convert the length here from meters to centimeters, which means I need to apply the conversion factor twice. Right? And we can see how that works using the same trick where we apply conversion factors above and below the line, right? So if I had forgotten this, and I was just going to say, oh, I just need to convert meters to centimeters, I would apply my rule, and I would say that there are 100 centimeters in a meter, where I've written this conversion factor so that the centimeters are on top and the meters are on the bottom. Okay, and now when I go to cross out my units, I would see, oh my goodness, only one of them cancels, right? Because this is meters times meters. So when I divide by meters, I can only cross out the 2 and I still left over with the meters. So if I just stopped at this point, I wouldn't be converting into square centimeters. I'd be converting into some weird hybrid unit of meters times centimeters. So that should be a red flag that you need to keep going and you're not finished yet. And so if I apply the same conversion factor again, right? You can think about it, the first time I applied it, it was for the x direction, and the second time I applied it was for the y direction. Now I apply that conversion factor again, and now this meters cancels out the leftover remaining meters, and now I have centimeters times centimeters, or centimeters squared, right? And so this is going to be equal to, right, we've got 10.2, I'm going to multiply by 100, and then I'm going to multiply by 100 again. And this would be easier to do in scientific notation, but we can still do it in regular notation. So this would be 102,000 square centimeters. Everything about this should make you feel a little bit uneasy. Clearly, this number here has 3 sig figs, and this number here has 3 sig figs, but I don't like expressing it that way, right? I want to express it in a way that makes it absolutely clear which of these zeros are significant. In this case, we happen to know it's none of them. So we can rewrite this in scientific notation. Take a second and do that on your own. Make sure you've got it right, right? And so we have 10.2, no, we have 1.02 times 10 to the 5th square centimeters, okay? And we can do that here just checking the powers. This should be 10 to the power of 1. And then each of these hundreds is a 10 to the power of 2. Whoops. So it makes perfect sense that it would be about 1 times 10 to the power of 5, because 10 to the 1 plus 10 to the 2 plus 10 to the 2 is 10 to the 5th. Okay? So that's just kind of closing the loop on all of this and showing you how to do it both in the conventional notation and if we were to apply scientific notation for unit conversions. Okay, so another conversion factor involves volume, and sometimes this can be a little bit confusing. It's natural to measure volume in terms of liters and milliliters. That is the metric unit of volume that we're most familiar with. But of course, if you're actually measuring separate dimensions of something and then calculating a volume, for example, if I measure the length and I measure the width and I measure the height of something, I can multiply all those together to calculate the volume of that area, okay? Or of that region of space. And so there has to be a conversion from milliliters or liters to, say, cubic meters. And so that's what we're going to talk about right now. The conversion factor is 1 centimeter cubed is equal to 1 milliliter. Okay? So that's our conversion factor. And then milliliter is just basically, if you wanted to know how many milliliters are in a liter, you should just be able to use the information about the prefix. Milli works the same here like it did everywhere else. So if you have 0.001 liters, that's going to equal 10 to the minus 3 liters, or 1 milliliter. Okay, so that's how we're going to be able to convert from milliliters to liters. So let's go through a quick example here. Say that you've done a measurement and you decided that the volume of a sphere was equal to 98.4 cubic centimeters. And so you wanted to figure out how much water that would displace in milliliters, or sorry, in liters, okay? We would then use conversion factors to first go from centimeters cubed to milliliters, right? So that means I need to say that 1 milliliter is equal to 1 centimeter cubed, where I've positioned my units properly, okay? And in this case, we're using centimeters cubed here and centimeters cubed here. So this whole thing cancels, this whole thing cancels, and now we've converted it into milliliters. And now I need to convert to liters, right? So I can use 10 to the minus 3 liters is equal to 1 milliliter. And again, I've taken my conversion factor up here and I've applied it in the appropriate way above and below the line, so my units cancel and I'm left with liters like I wanted, right? So now I just multiply my 98.4 by 10 to the minus 3, and I would get 0.0984 liters. Okay? You could also write this in scientific notation. I'll give you a second. Try that on your own. Pause the video if you need to. It's 9.84 times 10 to the minus 2 liters. Okay, hopefully this, with the previous video, gives you sufficient help to work through any sticking points that you had on these concepts going forward.